All right, so lesson 2 has us identify what type of data is given to us in each one of these situations, whether it's numerical or categorical, or if it's a single variable or multiple variables, right? So, and then it goes into asking us what is the best for this type of data set. Exercise that some more. All right, so let's go ahead and get into this. So this is the number of houses. So this is a frequency, a number of houses that are in different price ranges, which is $1. Right, so this is a frequency versus one variable. Right, so this is going to be a numerical because dollars are numerical, and this is going to be univariate data. Okay. The types of houses sold in Broward County. So that's definitely going to be categorical because there's no numbers involved with this at all. And it's just the types of houses, so we're only taking a look at one variable. Okay. Now here's the average number of houses sold. So this is a frequency. Okay. In different price ranges. Okay. That's a dollar range. And the average time. All right. So this is numerical and it's bivariate data. Two variables. The time and the dollar amount. Okay. So here's another one here. We're going to have Greg have these market for new SUV. This is the same as last one. Right. So this is obviously numerical data, and this is just a frequency. So this is a univariate data set, numerical and univariate data set. All right. So because this is such a large number, right? Scatter plot doesn't make much sense because that's even larger numbers. Okay, so don't use a scatter plot. We might be able to use a box plot, but I mean, it doesn't really help us too much because the data set's fairly widespread or fairly close together. I mean, so I would maybe look at other options. Okay, this is the best. Which one's the best? A line plot. The line plot's not going to make much sense because there's not a lot of duplicates in here, so not a line plot. A histogram would make sense, right? A histogram makes sense because it allows for fuel efficiency to be split into bins. Stem and leaf, probably not, because you're not going to have duplicate data. Bar graph, no, that's not going to make sense. Circle graph doesn't really fit the context here. So histogram's the way it's going to go. All right, so let's figure out what the number of bins are going to be. All right, so we have bins. The lowest is, let me pick a different color here. The lowest is, it looks like 11.0, 11.6 is the lowest. And then the highest is like 20. It says 22. Anything higher than 22. Looks like 22.5 is the highest. Yeah, okay. So let's see what our range is here. The range is going to be 11 points, or 22, 22.5, 22.5. And then we're going to divide that by, or subtract 11.6. That's going to be 10.9. So our range is 10.9. And we need to split that up into some number of bins. How many data sets do I have? There's 12 choices. So n equals 12. And a good idea for the number of bins of that is take the square root of 12. So 12 square root is like 3.4. Let's just round that up to 4. Okay, so we're going to use 4 bins. And how much should each bin be? Well, we're going to take the range and divide it by 4. So we're going to take 10.9 and divide it by 4. And it's like 2.75 or 2.72. So let's make it between, each bin is going to be 2.75 longer. Yeah, that makes sense. All right, so our bin 1 is going to be our lowest, 11.6 plus 2.75. So anything falls between that and like we'll just do 5.5. Or, well, wait a minute. Hold on. What's type here? 11.6 plus 2.75. Yeah, so it's a 14. We'll just do 14.4. 14.4. That's going to be our bin 1. Our bin 2 is going to be 14. Will be 14.5 plus 1 or 2.75. So 14.5 plus 2.75 is like 17.25. So 17.3. Bin 2. Then we'll do bin 3 will be 17.4 all the way up to whatever 17.4 plus 2.75 is, and it's 20, well, it's 20.15, so we're going to do 20.2. 20.2, and then we'll do 20.3 all the way to 22 to our maximum, 22.5. And that'll cover everything. All right, so how many do we have between 11.6 and 11.4? Let's count them. All right, 11.6 and 11.4. Or 14.4, excuse me. 11.1. Any other 11s? I don't see. Yeah, about a 12. I don't see any 12s. Nope. I have a 13. That's 2. And then a 14. That's 3. So I have 3 in that bin. Okay. Now, how about my other bin? Let's choose a different color. How about 14.5 all the way up to 17.3? All right, so do I have anything in the 15s? Yep. I have a 16 there. It's 2. 17.2. That's just the threshold of it. So it looks like I have 3 there. How many do I have in another bin between the range 17.4? So there's an 18 and 22. Okay, so those 2, that one, and that one. So I have 4 in there. And then, 5. I have 5 in there. And then we only have 1 at the high range, 22.5. Okay, so it's going to look like this. Well, we have bin 1, bin 2, bin 3, and bin 4, which represent these numbers. And we have 3, another 3, a 5, and then a 1. And that kind of shows us the distribution of the data based upon the bin ranges that we chose. Okay, so there's that. Moving on to here, this is a bivariate data. because this is one variable and this is the other variable. And since this one has a good number of points, I use a scatter plot for this. Bivariate, that's because bivariate numbers, because it's bivariate and it has and many numbers, many data set numbers. Okay, and then we're supposed to create this. So all we're gonna do is kind of work them from elevation. Which one do we want to make our x, and which one are we going to make our y? I'm going to make this y. I'll make this y. I'll make this y. I'll make this x. Saying that the elevation at sea level kind of drives a number of clear days, and let's see. So that's x. That's y. So at 102, it's 45. So let's make each one of these like 500. So this would be like a 0. This is hundreds of feet. And let me do this with this. All right, so this will be 5,000, 1,500 feet, 2,000 feet, 2,500 feet. This will be 3,000 feet, 3,500 feet. This will be 4,000 feet, 4,500 feet, and 5,000 feet. Because that's everything bigger than that. Okay. And over here, number of clear days. The most we have is like just under 200, and the least I have is just over 45. So I'm gonna go like 40 to 200. I guess I can go 0 to 200. That's fine. So this will be 200. This will be 180. We'll go by series of 2. This will be 160, 140, 120, 100, 80, 60, 40, 20, 0. Okay. So I'll bring this down so it starts at 0 right there. 20, 40, 60, 80, 100. 1. Okay. So there we go. That's what we're going to use for our data points. Oops, those didn't line up real great. Let's redo that. That's whatever. One probably didn't line up like I wanted it to. But anyway. So here we go at how many at, let's take a look. At 102 it was 45. So 102 is my x and 45 is my y. Oh, this is in thousands of feet, remember. Okay, elevation of sea level. So this is 102. It's like right here. And it's at 45. It's like 20, 45. Okay, that's the first one. Second one is at 141 feet above sea level. Why did I go up to 5? Oh, yeah, at 141 above sea level. So, like right here, it's going to be 102. So 20, 40, 60, 80, 100. It's like right there. Right, and you continue this process until you have some dots. When you're all done with this one, it's going to look something like this. a couple of these outliers way over here at 2,500 and some stuff, all the way out to 100. And here, and then down to here. So it kind of does like this. But you don't have to put the line in there. That's the scatter plot. It just gives you a distribution of the data. Okay, that's a little tedious question, but it's even tedious when you're trying to do it on a computer. So do your best with what you got. I hope it helps.